Hello, and welcome to an American AVK online webinar. My name's Wess Martin, and I'm a Territory Manager for American AVK. We'd like to thank you for joining us today, and we are bringing you the overview on the Series 66 gate valve from American AVK. The American AVK Series 66 gate valve uses same high-quality design and value components as our Series 45 and 65 gate valves, with the added benefit of PE pipe connections. So now let's go over gate valves. What exactly are gate valves and what are they used for? Gate valves are one of the most common valves used in water distribution systems and are suitable for both above ground and underground installations. Gate valves are often used when minimum pressure loss and full bore is needed. When fully open, a typical gate valve has no obstruction in the flow path, resulting in very low pressure loss. This design also makes it possible to use a pipe cleaning pig. The gate valve has to turn multiple times to go from the open to the closed position. This slow operation prevents water hammer effects. However, if you need a valve to open fast or close quickly in an emergency condition or control flow, a gate valve is not your best choice. The Bonnet Gasket, Wiper Ring, O-Ring, Stem Seals, and O-Ring Gland Seal are NBR ASTM D2000. The wedge is ductile iron encapsulated EPDM rubber. The standard coating on the Series 66 wedge is EPDM. EPDM stands for ethylene propylene diene-monomer. The American AVK EPDM rubber compound is approved to NSF 61 standards for contact with drinking water and does not impart any rubber taste or odor in the water. The AVK EPDM is a synthetic rubber compound that is resistant to sunlight, ozone, chlorine, chloramines, rubber set, and tearing or cuts. An optional coating on the Series 66 wedge is available, and that is NBR. NBR stands for nitrile butadiene rubber, which is sometimes referred to as Buna-N or simply as nitrile. NBR is not approved to NSF 61 for long-term contact with drinking water and will impart a rubber taste into the water. The AVK rubber compound is resistant to mild acids, petroleum-based oils, greases, and other organic compounds sometimes found in wastewater. It is also resistant to rubber set, tearing, and cuts. It is not resistant to long-term exposure to sunlight or ozone. The bronze wedge nut is locked into the pocket located at the top of the ductile iron core of the wedge. The surrounding ductile iron does not allow for deformation of the bronze under heavy compression loads such as over-torquing the valve in the closed direction. This allows the American AVK gate valve to withstand much higher closing torques that were required by the AWWA C515. For example, a 6-inch American AVK gate valve equipped with the standard stainless steel stem can withstand a closing torque of 1,800 foot-pounds and still be operable, where the AWWA standard only requires that it survive a closing torque of 350 foot-pounds. The Bonnet Gasket on all AVK gate valves is an O-ring type gasket that wraps around each bonnet bolt. This design not only provides an excellent high-pressure seal against leaks, but also protects each bonnet bolt from the corrosive effects of water inside and outside of the valve. The position of the gasket is maintained under pressure by the bonnet bolts and the groove that is cast into the underside of the bonnet sealing surface. The standard synthetic rubber material for the gasket is NBR to resist fermentation from organic compounds in the surrounding soil. However, an optional EPDM gasket is available for special applications. The NBR and EPDM gaskets are resistant to rubber set. In other words, after use, the gasket will return to its original shape and thickness so it can be reused. The standard stem is 430F stainless steel for potable water applications, but low zinc bronze, 304 stainless steel, and 316 stainless steel stems are available as options. The standard 430F grade stainless steel stem threads are rolled, not cut, to ensure smooth thread edges for smooth valve operation and a work-hardened surface to resist wear. The 430F material is highly resistant to corrosion in applications where it's exposed to potable water. The optional 304 and 316 stainless steel stems offer direct properties compared to the 430F low zinc stems. Stainless steel stems do not contain lead, zinc, or aluminum, so they are superior to the bronze stems in applications with continuous contact with drinking water. The 304 stainless steel stem offers corrosion resistance approximately equal to that of the 430F. However, the 304 material has a lower yield strength. The 316 stainless steel stem offers corrosion resistance that is better than the standard 430F. However, the 316 material also has a lower yield strength. The Series 66 gate valve is fusion bonded epoxy per AWWA C550. A holiday-free interior epoxy powder coating is optional. The pipe material is PE 4710. The DR required is dependent upon the pressure requirements of the system and will be listed in the project specifications. PE 4710 is suitable for butt fusion or electrofusion joining and complies with AWWA C906. The Series 66 gate valves are rated to a working pressure of 250 psi and are tested to AWWA C515, the AWWA standard for reduced wall resilient seat gate valves for water supply service. The pressure testing is performed on the valve before the PE ends are installed. The valve is shell tested to twice the rated working pressure and seat tested at a rated working pressure. Although this valve is rated to a working pressure of 250 psi, most waterwork applications operate at 50 to 80 psi. So in addition to seat testing this valve at the rated working pressure as required by AWWA C515, AVK performs an additional seat test at 30 psi. AVK performs this additional seat test to ensure that the valve maintains a leak-free, tight seal even at low pressures. As you can see in this slide, we have an image of our testing. Please note that every one of our valves go through independent testing before they are shipped off to their customers. So we test every single valve that leaves American AVK's factory. HDPE, or high-density polyethylene, is currently the dominant material used in water, gas, and sewage lines in Europe. In North America, HDPE is used heavily in the gas, wastewater, and industrial applications. It is gaining popularity for potable water lines as well. As it does not leak, it's resistant to corrosion, does not allow biological growth in the pipeline, and has a superior seismic resistance. HDPE stands for high-density polyethylene and is often abbreviated as PE. HDPE is typically used for water and sewage applications. Why is HDPE gaining popularity, and what are the key advantages over iron pipe? PE pipe can absorb 2 times its maximum operating pressure if a surge event such as a water hammer occurs. Due to the flexibility of PE pipe, the water hammer energy is absorbed quickly and does not cause damage to the more rigid components of the pipe system. Ductile iron and PVC pipe, on the other hand, are very rigid and will therefore transmit the water hammer energy a great distance through the pipe until the energy finds a weak spot in the pipe and may rupture the pipeline. This flexibility also allows the PE pipe to bend and flex without rupture when exposed to seismic events, freeze or thaw, and soil constriction. It is also so flexible it can be bent around cul-de-sacs. PE pipe has a very smooth inner surface when compared to the rough surfaces around the inside of iron pipe. This means that water flows through PE pipe much smoother with less resistance, lowering pumping cost. PE pipe ends can be fused together to form a self-restrained, leak-free pipe system. The fused joints are in fact stronger than the pipe surrounding the joint, and PE pipe systems will last over 100 years with no pitting, cracking, corroding, or any other typical failure problems of iron pipe systems. In fact, PE has the lowest failure rate in the market. Of course, there are a couple of items to consider before using PE pipe. PE has a maximum operating pressure of 335 psi, and the flexibility of PE makes it relatively softer than PVC or iron pipe. It is therefore more susceptible to cuts and gouges. If PE pipe is specified in your installation, the American AVK Series 66 gate valve with HDPE fusible ends is a perfect choice, and because you don't want bolted joints in your PE system, PE ends for AVK fire hydrants are also available. Boltless pipe assembly means corrosion-free and leak-free joints for a long-lasting pipe system. The HDPE pipe ends can be purchased in either iron pipe size, known as IPS, or ductile iron pipe size, known as DIPS, and are available in the following DRs: 9, 11, 13, 5, and 17. But please note that only 2-inch and 3-inch valves are available in the DR17. DR11, which has a maximum operating pressure of 200 psi, is the most commonly ordered. The DR of a pipe is a diameter ratio, also known as SDR or standard diameter ratio. DR compares the wall thickness of a pipe to its outside diameter. So a DR9, for example, would mean that the outside diameter is 9 times the thickness of the wall. The DR determines the maximum operating pressure the pipe can withstand. Another example is a DR17 pipe. It can withstand a maximum operating pressure of 125 psi, while a DR9 can withstand up to 250 psi. A high DR means the wall is thin compared to the pipe diameter. A low DR means the pipe wall is thick compared to the pipe diameter. Therefore, a lower dimension ratio means a higher maximum operating pressure. The required operating pressure of the installation should always be considered when selecting the DR so that the system is not over or under engineered. AVK also offers an MJ to PE pipe transition fitting to connect to PE pipe within an existing iron pipe system. This fitting has a ductile iron female MJ end that is rated to working pressure of 250 psi. We've also incorporated a lifting eye, making assembly to an existing pipeline easier. When an order is received, the PE pipe stubs are installed. The order will specify IPS or DIPS and the DR of the pipe ends. The pipe stubs comply with AWWAC 906 standard for PE pressure pipe and fittings. The connection is made by pressing a section of PE pipe onto the serrated spigot on the end of the valve. The pipe end is secured with a high-strength steel compression ring which forces the pipe into the valve's serrated spigots. The entire joint is then sealed with a heat-activated shrink sleeve to ensure the steel ring is protected from corrosion. The covering complies with the requirements of AWWAC 216, the AWWA standard for heat-shrinkable cross-link protective coatings. The Series 66 gate valve conforms to the requirements of AWWAC 515, the standard for reduced wall resiliency gate valves for water supply service, and is in compliance with NSF 61 and 372 standards for drinking water system components. This valve is not UL listed or FM approved, as neither of these agencies have standards which cover valves with PE ends. The Series 66 gate valves range from 2-inch to 16-inch. They come standard as an NRS non-rising stem configuration with an op nut, and a hand wheel is optional. The valves can also be ordered as an OSMY, also known as an outside stemming yoke. Configuration can be supplied with a special mounting flange along with a specially machined stem so that the actuator may be installed on the valve. However, these valves are typically used in underground installations, so these options are rarely requested. The Series 66 can also be supplied with options similar to our other gate valves, such as post indicator plate and a polyurethane outer coating, and all of the internal components of the Series 66, such as the seals, gaskets, stem bushing, wedge, thrust collar, gland flange, wrench nuts, and hand wheels are interchangeable with the components from the AVK Series 65 gate valves. Make sure you check out AmericanAVK.com. This is where you can find data sheets, brochures, maintenance and installation videos, and manuals, contact information, and you can become AVK certified, as we have 25 courses to bring up your expertise in AVK products. And also be sure to check out our virtual factory tour. Again, my name is Wess Martin, Territory Manager for Nevada, Utah, Arizona, and Northern California. My information is currently on the screen, and if you're not in my market, feel free to give customer service a call at that number, and they'll link you up with the nearest Territory Manager. Thank you for watching this webinar, and have a great day.